Dear students, now we are going to our next chapter, normal, unitary and self-adjoint. Normal, unitary and self-adjoint operators. So, consider that A is a, now we are going to important definitions. Let A is in BLH. A is a bounded linear operator on H, where H be in bird space. H be in bird space. Then, if A satisfies this condition, that is A star equals A. What is A star? It is adjoint of A. If A star equals A, then A is said to be self-adjoint. Self-adjoint, or A is said to be Hermitian. This another name is Hermitian. A is said to be self-adjoint or A is Hermitian. That is, suppose A star equals A means A is self-adjoint. Now consider this inner product AXY for all x, y following H. Consider inner product AXY for all x, y following H. This inner product AXY is, we know that it is inner product X A star Y. That equals inner product, but we know A star equals A since A is Hermitian, that is inner product X A Y. So when A is self-adjoint or A is Hermitian, then inner product X Y equals inner product X A Y. Okay, so this is an important relation. If A is self-adjoint, that means A star equals A, then inner product AXY equals inner product X AY for all x, y for H. So we know what is I star. We already proved this one. I star equals I. So identity operator. I is always known as identity operator. So identity operator is a Hermitian operator or a self-adjoint operator. Identity operator is self-adjoint. What is a zero operator? We know 0 of x equals 0 itself. So 0 star is again 0. So 0 operator is also Hermitian operator or self-adjoint operator. Also, suppose now as we are going to some results. That is, if A and B are self-adjoint, then A plus B is also self-adjoint, and AB is also self-adjoint when A and then they are commutes and so on. So we are going to an important result. Let A be a self-adjoint operator on H. A is in BLH. A is a bounded linear operator on H which is self-adjoint. That is A star equals E. Then inner product AXX. Inner product AXX equals 0 if and only if A equals inner product AXX equals 0 if and only if A equals 0. How to prove this one? So if A equals 0, its reverse inversion is immediate. If A equals 0, then surely inner product AXX equals 0. Why? Because when A equals 0, A is a 0 operator, AX equals 0. So inner product AX means inner product 0x, that equals 0 itself. So when A equals 0, result is immediate. Reversely, suppose if possible, inner product AYY equals 0 for all y following H. Reversely, if inner product AYY equals 0 for all y following H, you can replace x by y. So put a y equals x plus AX. Since x following H, AX also following H, A is from H to H, clearly y following H. So this you can replace this y by x plus AX. So that means 0 equals inner product AYY, that equals inner product A, what is y? X plus AX, comma, x plus AX equals 0. Sorry, x, that is 0. So which equals inner product ax plus a square x comma x ax. So if you open this one, this should imply 0 equals inner product axx plus inner product axax plus inner product a square xx plus inner product a square x ax. Okay. So inner product axx, we know inner product ayy equals 0 for all y fall in H. Therefore inner product axx goes to 0. Okay. Then for all, now inner product axx ayy equals 0 for all y fall in H means inner product axx equals 0 for all x fall in H. Now what is inner product a square x ax? You consider this inner product a square x ax separately. Put a z equals ax. Here inner product, now consider inner product a square x ax. This is nothing but inner product a square x means a ax ax. Okay. Put this ax equals z. Ax equals h. So this becomes inner product a z z. For all, since x fall in H, ax also fall in H, that's z fall in H. So inner product a z z. Since inner product ayy equals 0, inner product azz equals 0, so this also goes to 0. Okay. Now, consider inner product a square x x. This inner product a square x x is inner product a ax x. That equals inner product ax a star x. But it is given a is self-adjoint, so this a star is again ax. So there are finally we have 0 equals inner product axx plus inner product axx, that is 2 into inner product ax as inner product axx. So ax. So inner product 2 into inner product axx. 0 equals 2 into inner product axx means this implies ax equals 0. 2 into inner product axx equals 0. 2 differs from 0. Only possibility x equals 0. X equals 0 means a equals 0 because a is a, then that means a is a 0 operator. So when a is self-adjoint means a star equals a, then when a is self-adjoint, then inner product x equals 0 implies and is implied by a equals 0. Clear?